Have you ever wondered how mass spectrometry works? An intriguing question, isn't it? Mass spectrometry is a powerful tool, a technique that's fundamental in diverse domains, from unlocking the secrets of the universe in research labs to diagnosing diseases in medical laboratories to keeping an eye on our environment. It's an essential cog in the wheel of scientific discovery and technological advancement. So, what makes it so vital? In the next few minutes, we will unravel the mystery of mass spectrometry together. So what exactly is mass spectrometry? At its core, mass spectrometry is a powerful analytical tool used to measure the mass of particles. It sounds complex, but think of it like a giant scale that weighs molecules. But instead of measuring in pounds or kilograms, we're talking about atomic mass units. This technique isn't just about weighing molecules, it's also about identifying them. Through mass spectrometry, we can determine the elemental composition of a sample or molecule. It's like a detective tool for scientists, helping them figure out what something is made of at the most fundamental level. So whether you're a chemist studying complex compounds, a biologist exploring the intricacies of a cell, or an astrophysicist probing the mysteries of the universe, mass spectrometry offers a window into the unseen world of atoms and molecules. Now that we know what mass spectrometry is, let's dive into how it works. A mass spectrometer is a complex device, but don't worry, we'll simplify it for you. Imagine a mass spectrometer as an orchestra, each instrument playing a crucial role to create a harmonious symphony of scientific discovery. The three main components of this orchestra are the ion source, the mass analyzer, and the detector. Let's first tune into the ion source. This is the section where the sample, our soloist for the day, steps into the limelight. The ion source has a pivotal role in converting molecules from the sample into charged ions. It's a bit like a conductor, setting the tone for the performance. The ion source uses techniques like electron impact or chemical ionization to charge the molecules. Once ionized, these molecules are ready to step onto the grand stage of the mass analyzer. Next, we have the mass analyzer, the heart of the mass spectrometer. The mass analyzer separates ions based on their mass-to-charge ratio. Just like sorting an orchestra by instrument, the mass analyzer organizes ions by their specific characteristics. There are several types of mass analyzers, including quadrupole and time-of-flight, each with their unique way of sorting ions. Lastly, we have the detector, the attentive audience to the symphony. The detector's job is to sense and record the separated ions. It measures the abundance of each ion type, creating a mass spectrum. This spectrum is like a unique tune, a signature melody that allows us to identify the composition of the sample. But a detector doesn't just listen, it translates the symphony into a language we can understand, converting ion impacts into an electrical signal. This signal is then amplified and processed, creating a graphical representation of the mass spectrum. Each of these components, the ion source, mass analyzer, and detector, they all play their part, contributing to the grand performance of the mass spectrometer. They work in harmony to transform a simple sample into a spectrum of information. These three components work together to make mass spectrometry possible. Now, let's take a closer look at the process of mass spectrometry. Our journey begins with ionization, the transformation of atoms or molecules into ions. This is the first and perhaps the most critical step in mass spectrometry. Why, you ask? Well, only ions can be manipulated by electric and magnetic fields, which makes them the ideal candidates for our process. In the ionization stage, the sample is bombarded with a beam of electrons. This causes some of the atoms or molecules to lose an electron and become positive ions. This may sound like a simple process, but it's a carefully choreographed dance that allows us to control the number and energy of these ions. After ionization, we move on to the next step, which is the separation of these ions. This is done based on their mass-to-charge ratio, often abbreviated as Mz. The ions are accelerated by an electric field, which gives them kinetic energy. They then enter a region with a magnetic field which deflects them. The extent of this deflection depends on the mass and charge of the ions. Lighter ions, or those with a higher charge, are deflected more than heavier ions, or those with a lower charge. This leads us to the third and final step in the process, the detection of these ions. Now you might be wondering, how do we detect these tiny particles? Well, we use an ion detector which converts the ion signal into an electrical one that we can measure. Each ion creates a small current when it hits the detector. By measuring this current, we can determine the number of ions and therefore the abundance of each ion type. The result of all these steps is a mass spectrum, a graph that shows the relative abundance of each ion type. This spectrum is like a fingerprint, unique to each molecule, and it can provide us with valuable information about the sample. But keep in mind, while mass spectrometry may seem straightforward, it's not a one-size-fits-all technique. Different types of mass spectrometers are used for different applications, and each has its own strengths and weaknesses. For example, some are better suited for analyzing large molecules, while others are designed for high-precision measurements. In the world of mass spectrometry, one thing is certain: there's always something new to learn and explore. It's a constantly evolving field with endless possibilities. And that's the process of mass spectrometry in a nutshell. You might be wondering, where is mass spectrometry used? Well, the applications of this fascinating technology are truly diverse and far-reaching. Let's start with the realm of chemistry. Mass spectrometry is a powerful tool for chemists, as it allows them to identify the components of a compound and its structure. This is done by measuring the mass-to-charge ratio of ions. This critical information helps chemists understand the nature of various compounds, leading to the development of new materials and drugs. Speaking of drugs, mass spectrometry plays a significant role in biochemistry and medicine. It helps in the identification of proteins, biomarkers, and metabolites, which are vital for understanding diseases and developing treatments. It is also used for drug discovery and development, as well as in the field of forensic toxicology to detect drugs and toxins in body fluids. Moving on, let's talk about geology. Ever wondered how old a rock or a fossil is? Geologists use mass spectrometry to date rocks and minerals by measuring the ratio of radioactive isotopes. This helps them understand the history of our planet and its geological processes. Now, let's launch this discussion into space. Yes, mass spectrometry is even used in space exploration. It's a key tool for understanding the composition of other planets and celestial bodies. For instance, it was used on the Mars rover missions to analyze the Martian soil and atmosphere, providing valuable insights into the red planet's potential for life. From chemistry labs and hospitals on Earth to rovers on Mars, mass spectrometry has made significant contributions. It's not just a tool, but a window that lets us peek into the very fabric of matter, be it a complex protein in our body or a soil sample from a distant planet. We're just scratching the surface here. The applications of mass spectrometry are as vast as they are varied, spanning across industries and fields of study. It's a testament to the versatility and power of this technology. Clearly, mass spectrometry has a wide range of applications. Let's quickly summarize what we have learned. Mass spectrometry, a powerful tool in analytical chemistry, allows us to identify unknown compounds within a sample, quantify known materials, and elucidate the structure and chemical properties of molecules. The heart of mass spectrometry is the mass spectrometer itself. This sophisticated instrument consists of three main components: the ion source, the mass analyzer, and the detector. The ion source ionizes the chemical sample. The mass analyzer sorts the ions by their masses using electric and magnetic fields. Lastly, the detector measures and amplifies the signal related to the number of ions striking it. The process of mass spectrometry is a marvel of science. It starts with the ionization of the molecules in the sample. These ions are then accelerated and deflected by magnetic fields according to their mass-to-charge ratio. The detector then records the charge induced by each ion to produce a mass spectrum that can be interpreted and analyzed. Mass spectrometry has a wide range of applications. It's used in pharmaceuticals for drug discovery and development, in forensics for toxicology testing, in environmental monitoring, and even in space exploration to study the composition of planets and moons. With this, we come to the end of our journey into the world of mass spectrometry. Thank you for joining us, and remember, science is always more fun when you understand it.